We're currently working on the linear functions review, and we're going to jump right into maybe a how to do these questions, perhaps the most efficient way as well. For number 1, we're talking about the slope of the line, and so the most efficient way might be thinking about slope as this rise in the run. So slope is a rise divided by a run. In this question, it looks like we're from one point to the next, we're falling 2, and we're going across 1, 2, 3, 4. So a negative 2 divided by 4, or if we simplify this, a negative 1/2. For number 2, it's a little bit of a longer question, and it asks which of the equations is not equivalent to the other. So all of them are in different forms, maybe except for the a and the d, and it's really hard to compare. You know, I can see that the slope is a negative 3 over 2 and a negative 3 over 2 and a negative 3 over 2, and I really don't know what the slope is for part C, so we might have to do a little bit of rearranging here to see which one is different. I might start with letter C and rearrange it just because I feel confident in rearranging general form into maybe a slope-intercept form so I can more appropriately compare, because right now the 3, the 2, and the negative 8 mean absolutely nothing. So what we'll do is we'll subtract some things to the right side. I'm going to subtract a 3x minus a 3x, add an 8, and then move them over to the other side. Notice their signs changed. Lastly, I'm going to divide both sides by 2, which is dividing every term by 2, and it leaves us with a y that equals a negative 3/2 x plus 4. Those actually are the same. So I feel like C and B are not going to be answers to the question because they are different. They're not like the others. For A and D, I'm starting with one of these to rearrange, and let's just start with a letter D and see if it's different than these ones. So we'll put the negative 3 over 2 into the bracket so we can maybe find our y-intercept. A y plus 2 is equal to a negative 3/2 x plus 3 over 2 times a 4. Many people are going to use their calculator and type it in and see what comes out. We do end up with a positive 6. At this point, we can subtract a 2 from each side, so minus 2, and we result in a negative 3/2 x. 6 minus the 2 makes a positive 4. I can actually see this is the exact same as those ones, so I feel like it's not going to be the one that's different. So my guess is it should be 2a. And if you wanted to try rearranging, you'll find it's very similar to the approach in part D, and it should be something different. In fact, your y-intercept should end up being a negative 4. For part 3, it's asking for the slope of each line, and they're intentionally given to be different styles of questions. In the first part, the slope between 2 points is a division of y2 minus y1 over x2 minus x1. Many students do find that it's helpful to label an x1 and a y1 and an x2 and a y2 to identify them going into the formula. And so our y2 minus our y1 is a 3 minus 7. Our x2 minus x1 is a 6 minus a negative 4. And if we have a negative 4 on the top and a positive 10 on the bottom, this tidies to become a negative 2 over 5. Feel free to use your calculator and say, turn this answer back into a fraction, and it'll simplify it for you. Or divide by 2, and there's a simplified fraction. Number 2 requires a little bit of rearranging, and I'm going to add the 2y over to this side for the intent of seeing this in slope-intercept form. Plus a 2y, plus a 2y. Done. Divide both sides by 2. So divide by 2, divide by 2, divide by 2, and we have a 5 over 2x plus a 7 over 2. What's the slope of this line? Again, in y equals mx plus b, there's my m. It's a 5 over 2. So a follow-up question asks if the lines in part A are parallel, perpendicular, or neither. For 2 lines to be parallel, the slopes should be the same. For perpendicular, we use the word negative with reciprocal. So this is sort of a flip, a negative reciprocal. And if it's neither of those cases, same slope or a negative reciprocal, then it's neither. So when I look at these two, did the sign change? Yes. Did it flip from a 2 over 5 to a 5 over 2? Yes. So I feel very confident that these are perpendicular because they flip and they change sign. As we continue, for number 4, we're asking for a bit of a longer question, which asks to write two equations, write the equations in general form for your line that goes through a point and is both parallel and perpendicular to a different line. So we're being asked for two lines. The first one we're going to say is parallel to this line, which means I know that our line should have a slope that is the same, 5 over 7. Notice this is in point slope form, and there's the slope. The rest of this means absolutely nothing to us. It's parallel. All we take out of it is the slope. It says that our point goes through a 4, 3, so there's our slope. So there's our slope and there's our point, which means we can go into point slope form and plug in everything that we have. Our y value is a 3, our slope is a 5 over 7, and our x value is a 4. If we want to turn this in, and this is the equation for our line, but if we want this in general form, we do need to get rid of the fractions, move it all over to one side so it equals 0, and keep our x term positive. So I'm going to get rid of this fraction to start. In doing so, I can times both sides by a 7 and get rid of that fraction. This gives us a 7y, subtract a 3 times 7, 21, is equal to a 5, that's all that's left over, in front of an x minus 4. Maybe two more steps. We're going to put the 5 into the bracket, 5x minus 20, and then a 7y minus a 21. And we're almost there. We're needing to take this all over to one side, and because the 5x is already positive, I want to keep it on this side. Everything is going to come over to the right side. So we have a 5x minus a 7y. This negative 21 is going to be adding over to the right side. So a negative 20, the positive 21 is going to become a positive 1. And there's your equation in general form for a point that goes through 4, 3 and has a slope that is parallel to this one. For the perpendicular one, it's going to be a very similar approach, so I'm going to start it off for us, but then we're going to let you attempt it. The slope is going to be a negative reciprocal going through the same location. So the only difference here, same exact math, but you're going to have a different slope. So start with point slope, a bit of rearranging to general form, and answers are again still at the back. For number 5, it asks to write an equation with an x-intercept and a y-intercept. Now this is actually a coordinate location of x, comma y. Visualize this. X-intercept of negative 3. That's an x and a y. A y-intercept of 5. So we can get our slope, which is y minus y over x minus x, being very careful with not going too fast. We have a 5 divided by positive 3 as our slope. And usually at this point we'd go into point slope form or point slope form, but because we have a very, very special point, a y-intercept, we can go y equals mx plus b. And there is a line in any form. For number 6, we're being asked to graph each equation, and this is in point slope form, general form, and slope-intercept form. And so each has different starting information. The first one is in point slope form, and we can pull out the slope, and we can pull out the point, and being very, very careful that we switch the signs to say negative 3 for x, positive 2 for y. We have a negative 3, positive 2 coordinate location with a slope of negative 2 over 1. Remember, every number is a fraction. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, and this trend continues, and a line begins to form. For letter C, similar setup. We have a positive 3 over 5 as our slope, and we have a y-intercept that is a negative 2. So starting at a negative 2, we can rise 1, 2, 3, run across 1, 2, 3, 4, 5. And enough of a distance to say there's our trend, there's our slope. For letter B, not as convenient a form, so we might have to rearrange general form to tell us more. Now, if we wanted to find x-intercepts and y-intercepts, this was a bit of a strategy we have also seen. We could say for a y-intercept, we can say that x is 0. And I'm going to try to be a bit efficient about this. If the x value was a 0, then the first term would wipe out because 2 times 0 doesn't exist. And so we have a negative 5 plus a 10 is 0. If we rearrange this, we can subtract a 10 over to the left side and divide both sides by a negative 5. Negative 10 divided by negative 5 is a positive 2. And there's our y-intercept. If we wanted to get our x-intercept, we could find when y equals 0. This would mean our middle term would not appear because negative 5 times 0 is gone. So we would be left with the 2x and the positive 10 that equals 0. Similarly, if we subtract the 10 to the right side and divide both sides by a 2, we have a negative 5 as our x-intercept. 2 dots make our line. Not the only approach to do that. We could have also rearranged it to slope-intercept form, but we've seen that before. Number 7 asks us to write an equation in slope-intercept form. The first one is intentionally convenient as we know the y-intercept. So if we can count our slope, rise 1, 2, 3, run across 1, 2, 3, 4. Our slope is 3/4. If we know our y-intercept is 1, and we're being asked for slope-intercept form, this becomes a very quick question. The intent for part 2 is that we don't actually know the y-intercept, so we have a little less convenient information. We can still get our slope, which is down 2 over 3, but we really don't have a y-intercept, so I might have to start with a bit of different information. A point. Let's choose one of these at random. Let's say 2 to the right, 1 up. Because we have a point and a slope, we must start with point-slope form. Again, the task is to get this into slope-intercept form, so a bit of a rearrange. If the negative 2/3 goes into the bracket, we have a negative 2/3 x plus a 4/3. You might need to use your calculator for this last arrow. Answer back into a fraction, 4/3. Lastly, we get to add the 1 to the right side, and the like term is the 4/3 with the positive 1. So the negative 2/3 is an x term and it doesn't change, but the 1 adds over, and we have 4/3 plus 1 makes 7/3. Again, that might be a calculator number crunch. So 7 over 3 as a decimal is about 2.3 repeated, which kind of makes sense that this is a 1, 2, and a third. In part B, it asks to use a point to verify each equation, and so I'll show what 1 looks like. And so if we pick a point on either of these, and I'll only do maybe part 1. If we pick a point that's on here, we want to make sure that it verifies or is true. That means if I plug in an input into this equation, does the output match what we expect? So our graph says that one point is plug in a 4, out should come a 4. So 4 comma 4 should be on this line. Is our equation correct? Well, let's plug in a 4 and see if a 4 does come out. Let's plug in a 4 for the x and see what comes out. Fingers crossed that it's a 4. 3/4 times 4, again, that might be a calculator number crunch, but you end up with a 4's canceling and a 3 results. So 3 plus 1, the y value is 4 when we plugged in a 4. So 4 comma 4 is on this equation, which means our equation for this is probably pretty good. For number 8, it's asking if the lines are parallel, perpendicular, or neither. Remember that they need to be a negative reciprocal for perpendicular, the same for parallel, and anything else for neither. These are flipped, so they are reciprocals, but the signs don't change, so this would be a neither. For part B, the negative 1 over 3 versus a positive 3 over 1 is perpendicular. 3/4, they are the same, so they are parallel. And for part D, 2 over 6 is actually 1 over 3 if you simplify it, versus a negative 3 over 1 if you write it as a fraction. Negative reciprocals, so these are perpendicular. For number 9, we're asked for a line with a slope of 3/5 and a rise of 9. What's the run? So slope is rise over run. If we plug in what we know, it might help guide what we're trying to do. Slope is 3/5. The rise, it says, is 9. What is the run? And if we do a bit of a cross multiply, we have 3 times the unknown run is a 5 times a 9. Lastly, divide both sides by 3, and the run should be 45 divided by 3, which is 15. Visually, we could try to draw some of that out, but this is probably the most simple way. For number 10, we are asked to determine the equation of a line through a point and a slope in slope-intercept form. Now this point is actually special because it is our y-intercept. When x is 0, our y-intercept is 4. So we have a slope that's 1/3 and a y-intercept that's 4 in slope-intercept form. There's our answer. Number 11 is an application question about being given 2 points. So hopefully you've read the question. And it says after 2 years, she has $760 in her account. That's a dot. So 2,760. After 5 years, she has more money, $1,450. There's another dot. 2 dots are enough to make a line. So after 5 years, it's a $1,450. We'll get you started with this question, but it asks between 2 points, write an equation to describe this relation in slope-intercept form. So we do need to get a slope first because we don't actually have anything other than 2 points. And if we do a 1450 minus a 760, all divided by a 5 minus 2, our equation for slope, we have, and we'll do a quick number crunch, 1450 minus 760, we have a 690 divided by a 3, which does tidy up to be a 33. A 230. So 230 is our slope, and we have a choice of points. So if we go to slope-intercept form, we can say y minus, and I'll choose maybe the first point, y minus 760 is 230 x minus 2, and this does need to be in slope-intercept form, so we'll do a little bit of distributing into the bracket. And many of these numbers you might be doing in your calculator because they are a little bit larger, but adding the 760 over, we have a negative 460 that is being added with the 760. We do get a positive 1220. So for this question, x represents the years, y represents the dollars, so we're talking kind of about a y-intercept of 1220 and increasing really, really fast, 230. So it kind of means that for our slope being 230, for every 1 year to the right, we rise up $230. So 230 is the dollars per year that Josie gets. The B value is, in this question, the fixed amount into the savings account at 0 years. So the original $1,220 is the amount of money at year 0, or the fixed amount at the beginning. How much will Josie have saved after 10 years? Well, we could say, well, let's input 10 and see what comes out. So we have a 230 times 10 plus a 1220. Out comes a 3520, $3,520 after 10 years. For number 12, we have an equation in general form for a line that goes through a point with a slope. So a point and a slope, point-slope form. Because we've done a few of these, we'll set it up again a little bit quickly. Y minus 2 equals slope x plus 1. And again, needing general form, we need to get rid of all fractions and decimals. So times everything by the 3, which would wipe that out. 3y subtract a 6 equals a 1 in front of an x plus 1. Moving everything over to the right side to equal 0, we've got an x minus a 3y plus a 6, with the 1 makes a 7, and there is general form. Number 13, a line can fit into the categories of increasing, decreasing, so positive, negative. A 0 slope is horizontal, and undefined is vertical. Undefined. Last few questions. A line has a slope and goes through 2 points. What is the unknown part of one of the points? So the slope is y minus y divided by x minus x. So we have a 3/4 that equals a y minus 4 divided by a negative 6 plus 2. That's a negative 4. I'm going to cross multiply this negative 4 up here to make a negative 12 over 4 that equals a y minus 4. In fact, negative 12 divided by 4 is a negative 3. And if we add the 4 to the right side, it tells us that y is equal to 4 minus 3, 1. So if you try a 1 into that y value, it should give us a slope of 3/4. And lastly, x and y-intercepts. We've done one of these similar on this review. And if we want to find the x-intercept, we want to say y equals 0. And this is visually because the x-intercept is when we haven't moved vertically any. That's at a y value of 0. So we can say 2x minus 5 times 0 is negative 10. 2x is negative 10. Divide both sides by 2. X-intercept is negative 5. For our y-intercept, we want to say x is 0, because then we haven't moved left or right any, and that's when we're on the y-axis. So 2 times 0 minus 5 times y is negative 10. A 0 subtract a 5 is negative 10. Divide both sides by a negative 5, and you get a positive 2 as your y-intercept. Good luck!